All right, everyone, welcome to the next lesson. In the previous lesson, we created basically our aggregator or client, so we can actually use both JSON API and also gRPC. And now we are actually, let me first open up, where am I actually, to be honest, here. Let me code into this folder, right? VS Code, let's boot that thing up like this. And we have some, this is too big for me, a little bit smaller, just like that, perfectly fine. I'm gonna basically close all editors, so we have a blank, beautifully terminal, right? So we had added Prometheus documentation readme. That's what I did basically today. I added some information about Prometheus, how we can start it up and all that shenanigans, but that's for later on. The first thing we're gonna do basically is our gateway, right? And basically a gateway is a user-facing API. It's a user-facing API that is only used by the end user. For example, let's say we built this beautiful tolling stack, right? And we're going to have a couple of in how it worked back in when I made this in the company I worked for. Basically, they're going to have a mobile app. For some people, they're going to have a UI. For some people, they're going to have a UI for administration. They're going to have a UI for the client, for the customers, right? So they can basically register and check all that stuff. So they all going to interact with the gateway, right? They're not going to interact with our services itself. They're going to interact with the gateway. So it's basically a very simple JSON API that sits in front of all our microservices, and it's going to handle the authentication, it's going to handle the whole shebang, and most of the time it's going to receive JSON, right? So that's basically what we're going to build, right? So what we're going to do is, and we are not going to use any framework for this, right? Because normally you could use a framework like Fiber, just like we used in the JSON API chapter. But I want to show you how you can basically build web service APIs completely from scratch, because I prefer to do it that way. And a lot of companies, it's just good to know. It's good to know. And trust me, if you know this, you're basically a champion, right? So, yes, all right. For me, it's Sunday, so I'm a bit rusty. Not gonna lie, and my apologizes. We're gonna say new folder. I'm gonna call this the gateway. Just like that, gateway. We're going to make a new file. It's going to be main.go, right? Perfectly fine. Where are we here? It's pasting a color. I was working on my website, that's why. So we're going to say package main here. We're going to say func main. All good, all good. We have this. Let me see my settings. Are we actually using? Yes, we do. All right, cool. No problem. All right. So basically, our main. The first thing we're going to do is actually set up some stuff, right? So how does HTTP and Golang normally works is you're going to have a handler here, right? Let's make a handler. Func, for example, what could be a handle? It's going to be handle get invoice, right? We're going to say, actually small caps, handle get invoice, right? It's basically the handler that's going to get an invoice. That's one of the endpoints we're going to make, because we are calculating distances, we are aggregating the distance, and then we're going to calculate the invoice, right? So that's that. So basically handle invoice, and we're going to say here, it's going to take in an HTTP response writer. Man, I'm so fucking rusty, not going to lie. There's going to be an HTTP request. Let's warm up, right? That's what it's going to do, right? And basically, why am I not importing HTTP? Because I made a mistake. Just like that, right? And basically what you could do is something like this. write. Right, the only thing we can do is actually write bytes. That's a little bit unfortunate, right? But we're going to fix that. For example, this is working just fine, right? Something like that. Okay, the next thing we're going to do is we're going to basically boot up our application, right? We need to make an HTTP server. In Golang, it's actually very simple, right? We're going to do something like this. HTTP listen and serve. And then we're going to specify a port. For example, let's say it's going to be port, I don't know, 6000 or something. And then this takes in a handler, which is just nil, right? Don't worry about that thing. So that's our HTTP server. The next thing we're going to do is we need to, because we need to have an endpoint, right? Slash invoice or whatever, right? So we're going to say HTTP handle func, is it called, right? And then we need to specify what it's going to handle, what kind of path, what is the route, right? For example, it's going to be invoice, for example, like that, and maybe, yeah, invoice, for example, right? And then we're going to say here, or handler, right? You can see the pattern here. The pattern is the route, and then the handler is basically this function, right? And it's basically this function, right? So what we could do is basically just handle get invoice and call it a day, just the pointer receiver of that function, right? That's all good, all good. We could do a log fatal here, right? Remember, so we know if something is wrong, just like that. And then basically what we could do, let's open up our make file because we need to make the gateway, right? We're going to say gateway. Let's call it gate, right? Gate. And that's going to be, let's copy this one, paste that in. It's going to be bin gate gateway main.go, that's fine. And then we're going to say here /bin gate, right, to boot it up. All right, let's go back to main. Can we do make gate? Right, so it's basically running. We don't see anything, so let's fix that real quick. Let's go to quick, I mean. Main gate. That's where I need to be, this one. So let's do something like fmt println, or we could use our logrus, right? You could say logrus info HTTP, let's call it gateway, right? Gateway HTTP server running on port. In this case, it's going to be 6000 hard coded. We're going to fix that, right? But let's just boot that up. Make gate. Well, and you can see info gateway HTTP server running on port 6000. What we're going to do is the same thing. We're going to say the listen adder here. It's going to be a flag.string, right? And we're going to call this a listen adder. And that's going to be default 6000 because we're going to have 3000 already occupied, I think. Not quite sure. And so for flag strings, basically, it's going to make that you can parse the flags from the command line, right? And this is the flag name. This is the default value. And this is going to be some information, right? It's going to be the listen address of the HTTP server, something like that, right? Boom. And then we're going to say flag parse, right? Flag parse. So Go can parse these flags. And then we have this listen adder. What we're going to do, we're going to basically say this. We're going to paste that in. We need to basically dereference this, right? So we're going to say listen adder. So we need to do this asterisk on top because this is a pointer, right? So we need to dereference that. Server running on port, and we could do something like this. Not quite sure if this is going to work actually. Do we have info F, by the way? Maybe we have. That's perfectly fine. So we can do something like this. %D. No, it's going to be S because it's a string. Let's do it like that. It's fine. And we're going to say the listen adder again, but we need to dereference that. Right. Okay, cool. So let's run this. Make gate. Boom. Now we're going to see we have basically port 6000, the default one. Hey, that's good news. Okay, the next thing we're going to do is we have this handle get invoice here. So what we're going to do is we're going to fix some stuff. First of all, let's test this real quick, right? Let's do a make gate, right? And what I'm going to do then is basically open up a Thunder client, if I can, just like that. So I'm going to say this http://localhost 6000, by the way. Yes, 6000 /invoice. That's what we need. And I'm going to send that. Boom. And then we're going to have a response, right? This is going to work. This is working just fine. Of course, it's a status 200, fine. But if you check the headers, it's going to be a text plain and all that stuff. And we don't want that, right? So we're going to fix that. First of all, let's kill this. The first thing we're going to do is make a helper function, right? And you can already see that we are basically writing everything in the main. There is no need to start these crazy folders in your gateway. No, it's a simple gateway, right? Most of the time, a gateway will start simple, and you're going to add more and more routes, and then you can basically scale your folders. But right now, it's not needed. Don't make it too complex. Func. So we're going to say here, this function is going to be write JSON, right? And to write JSON, we're going to say something like a code. No, first we need the HTTP. I think we already covered this somehow. Not quite sure. It's going to be the response writer. Yeah, response writer. We need writer, we need a code, which is going to be an int, and then we need something, a value, which is going to be an any type, right? And it's going to return an error here. And what we're going to do is, first of all, we're going to say w header. Then we're going to say add. Can we do that? I think it's a function here. Yeah, add. And then we're going to say content type. Content type is going to be I think we need to, small caps is fine. Application JSON, right? That's that. Then we're going to say w write header. And it's going to be the status code, right? So we're going to say the code. And then we're going to say return JSON new decoder, and we're going to give it a writer, right? If you check decoder, you're going to see it later on. If I save this, you're going to see it takes an IO reader, right? And an IO reader is an interface. So a new decoder can be destructed with any kind of thing that implements the IO reader, right? So in our case, the response writer is going to be an interface, but luckily for us, this response writer here is also exactly an IO reader. So we can do W, and then we're going to say decode here, and we're going to decode this value. I think it's going to be an encoder, by the way. My bad. An encoder, right? Encode. And that's going to take a writer, right? It's going to be an IO writer. My bad, guys. Hey, sometimes, forgive me. Cool. And instead of saying here, write, we are going to say something like write JSON, right? We're going to pass in the W, this response writer. Then we're going to say here, a code is going to be HTTP status OK, right? And then we're going to say a value could be something like a map string, for example, invoice. Can I please type? Yes. Invoice is going to be some invoice. Of course, this is just double string, but it's just to show you, right? And we need to... This is going to return an error, but there is no way for us to basically decently handle these errors, but we're going to fix that very soon. Let's make this real quick. Make aggregator, right? New request. We're going to send that out. We're going to have an error here. Oh, we made a... It's going to be... not the aggregator. Make... gate. Yeah, the gate, right? We're going to send that, and now we're going to see here the content type is application JSON, right? And the response is a beautiful JSON response. Hey, isn't that amazing, right? So that's the first thing. So you see, making these HTTP stuff in Golang is not that hard. The next problem we have, I don't like to have these headers here. First of all, a couple things, right? So the first thing is we don't have an error, right? So there is no way we can centralize our error handling. How can we fix that? Well, we're going to say here at top, we're going to say type, and we're going to call this an API func. And that's going to be a function. And that's going to take in a W HTTP response writer. Yeah. Actually, almost the same. It's also going to take an HTTP request, right? And for the people, one of my videos on YouTube covers this, right? It's called the decorator pattern or higher order functions, whatever you want to call it, right? And we're going to say that this API func is this, right? A response writer request, but also is going to return an error, right? So if we want to make our handle get invoice compatible, we need to return an error, right? So now this function here is basically the same as the API func, right? The problem is that handle get invoice here, it won't work because now we return an error. So the function signature is not correct, right? So now we need to make a converter, right? So I'm going to say here a helper function actually below func make API func, right? And that's going to take in an event, which is going to be an API func, right? And we are going to return an HTTP handler func. Handler func, right? That's what we're going to do. We're going to return a function, which is an HTTP handler. And what is an HTTP handler func? Boom. It's this. It takes in a response and a request, right? So we're going to say W, HTTP response writer, but also a request pointed to an HTTP request, right? And then we're going to say, right? Now we're going to say this event, which is our API func, which is this handle get invoice, right? Now we're going to say, for example, if R is going to be event W R What's going on here, please? And the error is not nil. We're going to say something like write JSON W. We're going to say HTTP, for example, internal server error. And then we are going to return, for example, a map string of string. And we're going to say error. And then maybe this error something that we returned. But of course, if you want a string, you do it like that. Right? Something like this. So right now, this still is not compatible. But if we say, for example, make API func, and we pass in this handle get invoice, now everything is working fine. And this can be a little bit too overwhelming for you, but there's good news. You can replay this piece if you do not grasp it. It's very hard to grasp in the beginning. This is a very important aspect you need to understand, right? Because, hey, you need to. So feel free to come on the Discord. Feel free to send me a mail. Feel free to replay and ask me so you can understand this. This is very important, guys, right? This is the full-time GoDev program, so I really want you to understand this concept completely, right? All right, so now there's a problem, right? Because now we have an error, but we don't return an error. But that's nice because now we can just do this: return write JSON. Isn't that beautiful, right? So if I run this, make gate, for example, right? I open up my request here, and we're going to send. It's going to be some invoice, right? But what if we do main gate, for example, an error here? We're going to return an error, fmt error f, something went wrong. Boom. Make gate, new request, send, boom. And I'm going to have an internal server error, something went wrong. Right. Seems good to me. Gateway here, this will be, we don't need this, make file, all fine. So the next thing we're gonna do is, the next thing we're gonna do, right now, we don't have anything, like I'm building this up, right? You can see we started very small, and now we are building up. That's a very important aspect. That's what you need to do. Don't try to over-engineer. Do like me, start simple, test, add something else, test, and keep building, keep improving your own framework, so to say, right? Oh man, my nose is itching. Cool. The next thing is, what if we want, this handle get invoice is basically going to contact one of our services, right? It's going to contact, I think it's going to be the aggregator, right? Yeah, the aggregator. So how can we contact that? Because we need to probably have something like an aggregator client. Do we have that actually, to be honest? That's an aggregator client. But that's the client for... Now I'm confused. Where's data? Where's this? What's that? What the... Whoa! That's crazy. What's going on? Oh, view temp? What is temp? Oh, yeah. This is our RPC stuff. I'm gonna delete this temp, guys, because we're not gonna need this. Whoa, this is insane, this sound. I'm so sorry, guys. I'm thinking, because we have our OBU, this is calculator or aggregator, but this basically calls an aggregate request, right? It's for, this client is basically for, or distance calculator is using that, right? But that's no problem. But we need to call this aggregator, right? So now we need to have basically an aggregator client, but not the another client. Wait, because I'm making it too complex. Because listen, this aggregator, guys, we have let's open up main, right? So in our aggregator we have HTTP at 3000, but let's take a look here. Look, we have this, right? We have this aggregate, which is basically to aggregate stuff. It's being called by the distance calculator. But we also have an invoice endpoint, which we need to call, right? This is what the user is willing to see, willing to retrieve. But the gateway is some kind of a proxy, actually, right? The gateway is a proxy between between the users, the clients, the mobile apps, the whatever the fuck, and the services. So the gateway needs to sit in between. So we need to have a client. But that's nice, actually, to be honest, because what we could do is we can actually go to our client here, and now we're going to say here, for example, it's going to cause us some extra work, but we could say invoice. For example, get invoice, right? Which is probably going to take a context. Context, if you want to do, is good. And we're going to say types in, no, it's going to return a types invoice. We're going to say get invoice. Maybe we want to have some kind of an ID, right? So we're going to say integer, and it's going to return here types dot invoice, but we don't have, we added already. That's nice, and an error, right? That's what it's going to return. Of course, now we're going to have big problemas because this is not compatible anymore, right? This HTTP client, so we're going to fix that real quick, right? So we're going to make this real quick. So we're going to say, actually copy this thing here. Let's make it, let's put some speed behind this. So this is going to be get invoice. Invoice, yes. And we're going to say, it's going to take in, delete till this, an integer. Not quite sure what kind of ID we want. Maybe an OBU ID. Doesn't actually matter. We're going to say ID int. I'm going to return types invoice error. Right. Let's just return nil here. Right. Actually, to be honest, I want to see what is types invoice. Actually, it's a long time no see. Oh yeah, it's just this, right? That's fine. So we can go back to this thing here. Let's return a fake invoice for now. You see, what I'm doing to test this is just return something, some mock data, just to see, right? It's going to be a types invoice. That's going to be an OBU ID. Let's do some. Actually, there's going to be that int we give it, right? Let's do this ID, and then we're going to say distance. Total distance is going to be, I don't know, something weird, and then it's going to be total amount that they will need to pay. To be honest, and that's going to be I don't know. Some big money ish, right? That's fine. So now this is implemented. The problem, what's going to, oh yeah, so we cannot forget to basically update our gRPC client, right? But for now there is no error, so just let it not be compatible just for a little bit. Get invoice. Okay, now we have this client, which is beautiful, right? Because now what we need to do is back to our gateway. Gateway, right? So now we need to have a way in this handle get invoice here is access to the AG client, right? That's access. We need to have access to that. How do we do that? We can create a new client each time here, but that's basically BS. So what we're going to do is we're going to make a struct that will handle this invoice, right? So for example, we're going to call this func, the invoice handler. It's going to be a structure, and we're going to have a client, which is going to be a client, an interface, right? Boom. Func is going to be a type, by the way. And then we're going to say here, instead of making this handle invoice, we're going to say func, we're going to attach this function to this invoice handler, right? Handler pointed to an invoice handler, and we're going to say handle get invoice, right? Because now we have access to this client, right? We could say h client dot get invoice based on an ID we're going to get or something, right? For example, get invoice. We need a context, so we could do something like a context.background and then put this ID in, something like that. Now we have that, and that's going to return us an invoice or an error, right? And if r is not nil, VS Code really not really like it, but for the sake of this course, I'm going to use VS Code. We're going to return this error. And then we have an invoice here, so we can basically delete this, boom, and then return the invoice back to the client, right? Whatever client it's going to be, we don't know, right? That's not in the scope of this tutorial. We are backend engineers, right? Yeah, that seems good. Do we need something more? I don't think so. So we can actually test this a little bit. Of course, it's not going to be super connected, but it's going to test some stuff, right? So I'm going to say make gate, see if we have no errors. We have 19 is a problem. Let us see. Okay. Oh yeah, that's fine. First of all, we cannot call this handle get invoice because we have, we need to make a client first. So we're going to say client. Do we need an error here? It's going to be client, new HTTP client. We need an endpoint. We could actually say to do because we don't care about that. I don't think it's going to return multiple things. One is fine. Then we're going to say here that the invoice handler is going to be actually we're going to make a constructor here, right? We're going to say new invoice handler with a client. We're going to say client. We're going to construct that with a client. We're going to return a pointer to an invoice handler. And we're going to basically just return an invoice handler. And we're going to say that the client is going to be, the client is going to be C here, right? Something like that. So now we can say that the inf handler is going to be new invoice handler, passing in the client, right? And then we're going to say here inf handle get invoice, make API link, something like that. Now as everything is compatible here, we can actually do this. A beautiful var here, so we can align this, right? Boom, boom, boom. Look at that, beautiful. Yeah, I think now it's gonna work. Let's clear the screen and do a make gate. Boom, perfectly fine. So now if you do handle get invoice, and we're gonna see this beautiful result here, right, guys? See if you can see that. OBUID, it's mock data, right? We don't actually call HTTP yet, right? So that's fine. The next thing we're gonna do is now we're gonna basically make it better, right? So let's open up this HTTP client here, and we are gonna make a request to that thing. Do we have a get invoice request? We don't, right? So we need to make that, and because we're going to get that invoice request also from proto buffers, right? Look at this. Let me open up proto to show you this, right? So we have this aggregate request, and I think we're going to make a message here, which is going to be an invoice, a get invoice request. It's always a good idea. This is actually a very important thing. It's always a good idea to separate your requests data that's basically coming from a request, and the data you're actually using as your business logic. I mentioned this in a previous video or in a couple of videos back, right? Very important to understand. Get invoice request is pure transport based, right? The only thing we actually care about this, to be honest, is going to be an OBUID. Let's just do it with OBUID, OBUID, something like that. And which is going to be an N32 because it's proto buffer 1. Yeah. And this, let's make the OBUID simply the same as the other ones, like that, right? Because does it make sense to query that with an OBUID? Probably not, because this invoice is going to be an invoice based on all the OBUIDs driving for the same transportation firm, because you can have a transportation firm company. You're going to have 12 trucks driving on the road, which some of them will cross these toll roads. So you're going to basically aggregate all the information from all these OBUs and calculate the distance, calculate the invoice separately for each OBU, and then aggregate that invoice and return it back. But that's basically pure business logic implementation, right? So we are going to keep it simple here. So we're going to say OBUID is going to be 1. Of course, I'm going to have a problem here if I compile this. Look at this, make proto, because again, I have not, let me fix this real quick. Let me open up this. Yep, personal information here. Let me open up GitHub real quick. Golang micro I need. It's because I have a new machine and I didn't basically add this proto thing to my pad. So I'm going to copy some stuff, copy here, and I will show you what I'm going to paste actually, to be honest. I'm going to paste this, right? Pad, go, boom, enter. And then if I make proto, it's going to work all fine, right? Boom. You see? Now we're Gucci. I need to be in codes, by the way. Yes, here. All right, so now we are good. It's going to be compiled. Let's do it again for the. Oh yeah, I need to paste it in here. This is annoying. make proto. Well, now it's fine, right? We are good. So if you have the same error, make sure it's in your path, right? I'm gonna paste it one more time for you. If you have the same error, you see, you just need to copy this and paste that in. So I'm gonna keep it a little bit here so you can pause it and maybe do the same thing if you have the same problem. All right. Yeah, so now what we're gonna do in this HTTP client, what we're gonna do is we're gonna say wait, so it's gonna be, yeah, it's gonna be this. I'm thinking here real quick. Because we could actually just... No. We can call this with ID here. And constructor request here. We could do something like BR is going to be JSON Marshall. This, let's make the request here, which is going to be a types invoice request. Get invoice request, by the way. Get invoice request, right? It's going to take in an OBU ID, which is going to be that ID here, right? Of course, we need to make it an int32 for proto buffer. Hey, this is what it is. And then, actually, this request, let's make it an inf request so we don't have conflicting variables. We're going to say this inf request, right? If R is not null, we can return null here, right? Because null for the invoice and R for the error. Then we have bytes here. What we're going to do then is copy what we did here. We're going to make a new request, default client, status code. We're going to check all of that stuff, right? We're going to paste that in here. That's why I said don't conflicting names, right? This real quick. Of course, we need to return null because we have multiple returns here. The same thing here. If there's an error, we're returning null and the error. The same thing here, null and this error. All right, so then we're going to have a response, which is probably going to be this invoice response, which this is going to return a type invoice. Is perfectly fine. So I think what we could do is this, right? Let's delete this. Let's do var invoice is a pointer. Actually, to be honest, we can do no pointer types invoice, right? And then we're going to say if R is going to be JSON new decoder a response dot body dot decode everything into this into the pointer, into the ref, into the memory of invoice, and if the error is not null, we're gonna return null and the error. Otherwise, we have this if voice. We're also gonna do a defer response body close. Something actually we forgot to do, I guess. It's very important because you're going to close the body. It's cleaning up resources, right? We're going to clean up the resources to be sure. And let's copy this here. And we're going to do the same thing here, right? Where is our response? Yeah, we don't need to close this because... actually, to be honest, let's do that. Or this. Doesn't matter. Defer response body but close. That's fine. And then we're actually going to say return... this invoice, which needs to be a pointer, and null. What we also could do, but it's fine. This is perfectly fine. We have a problem here. Yeah, that's true. Do we need to do this? Yes, give it the pointer here. Perfectly fine. Here, here, and here. Yeah, so what's going to happen is, let's just make gate, and it's going to work out. And the reason why is because you will see, because we don't have our, you see, oh, it's an unsupported protocol scheme. That's true. That's because in our client, no, it's not. It's going to be in our main here, right? Look at this. We just, here, new HTTP client with an URL of to do. That's actually bad, right? So we're going to say here, it's going to be, I don't know, what port is the aggregator running, by the way, guys? I don't know. Middle client, where is our main here? 3000 is this guy, standard port, right? Yes, 3000. So what we need to do in our gateway is adjust this to an HTTP localhost 3000. That's fine. That's gonna be this thing. But the HTTP client is gonna call the endpoint, but /invoice in this case. Aggregate should do the same thing, to be honest, right? Aggregate. Of course, this is gonna have some problems. Where do we do this? It's gonna be in our distance calculator service. Where do we construct all that stuff? Probably here in main. Yeah, aggregate. That's not the endpoint. The endpoint is gonna be this one, right? That's gonna be the endpoint, and we are gonna set these endpoints how we want that, if you understand what I mean. So let's do this, make gate again. And we are going to go, you see that these microservices, they give you a lot of things to fix and to check, and a lot of dependencies of URLs and where do they run. And yeah, microservice is not that simple, right? It's not that simple. It's a little bit over engineering in most of the times, right? Where is my Thunder request here? Here is this bad boy. So we're gonna get invoice here, right? And now it's gonna say that the connection is refused, right? Of course, because we don't have the aggregator running, right? Let me see how much time we have left on the block. So what we can try real quick before we end this is basically boot up the whole shebang, right? Boot up our whole stack. Let's close this. Let's do a couple of these things here. Boom, 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 boom. What do we need? We need the... do I have my Docker running actually? Docker PS, probably not. Docker is not running. So I'm gonna... Actually, what I'm gonna do, let's do it in the next video. The next video, we're gonna boot everything up. We're gonna see if there are any errors. And we're gonna have our gateway connecting to... as a proxy, having that a gateway as a proxy between users facing stuff, mobile apps, front ends, admin apps, and all that stuff to our services, right? That's what is going to happen. And we're probably also going to start to basically instrument the aggregator, because I think the aggregator is going to be the perfect example. We're going to completely instrument. And what do I mean by instrument? Instrument is make the aggregator have perfect logging, make the aggregator have perfect metrics and all the shebang, right? That's a complete instrumented microservice as if it were gonna run in production on your day job or the company you're gonna work for, right? Of course, normally you should do every single microservice should be instrumented, but for the sake of, if I'm gonna show you this for the aggregator completely in detail, you can actually use that as all the others as an example to test and to practice, right? Cool. All right. Thanks for watching, and I'll see you in the next one.